In a previous video, I showed that the series from 1 to infinity of 1 over 2 to the n converges to 1 by taking a limit of a sequence of partial sums. What I'd like to do now, though, is take a different approach and again show that the infinite series converges to 1. But this time, using the fact that this is a geometric series. And so we can use the geometric series test on this. So geometric series have the general form a times r to the n. As n goes from 0 to infinity, they may go from 1 to infinity or even 3 to infinity. And that's actually not important where the series starts. It's more the infinite part, it's this tail end of the series that we're concerned with when we're checking whether a series converges or diverges. But the overall form that you're looking for, that you want to focus on, is the fact that you have a constant base raised to the n. So that's the signal that you're looking at a geometric series, which in this case, so the sum 1/2 plus 1/4 plus 1/8 and so on can be written as 1 over 2 all raised to the n. It is acceptable to take this constant 1 in the numerator and think of it as 1 to the n. If you're concerned about indeterminate forms and the fact that 1 to the infinity is an indeterminate form, this isn't a limit with the form 1 to infinity. This is actually 1. This is a constant 1. It's not something that's approaching 1. And so this numerator is, even if we express it as 1 to the n, it's still just 1. Okay, so we've got a geometric series. R is the base of this exponential expression, always. So in this case, r is 1/2. A, we should think of a as just the first term. That way, we don't need to be concerned with if the index here starts at 0 or 1 or 2 or whatever. If you just think of a as, in your head, be telling yourself first term. So when I say first term, I mean if you're going to expand this infinite sum, what's the first term in your sum? So you should plug in whatever your starting value is for n, you should plug that in to find your first term. So in this case, we're starting with n equals 1. So first term is 1 over 2 to the first. It's this 1/2 right here. I already had the expanded form up here. So in this case, a is 1/2. And the formula, when a geometric series converges, which this one does, by the way, they converge whenever the absolute value of r is strictly less than 1, which 1/2 satisfies that requirement. Then the formula for the infinite sum is a over 1 minus r, which in your head think of that as first term over 1 minus r is the common ratio. So first term over 1 minus the common ratio. So in this case, first term I said is 1/2 over 1 minus r is 1/2. So this is 1/2 over 1/2. So 1. So we've again shown that this infinite series converges to 1.